Welcome again to another edition of the Southwest Climate Podcast. Mike Crimmins.
Hey, Zach. How's it going?
Give me your best word.
Happy graduation day.
Happy graduation day.
Yeah, we're not graduating.
When did you
we're
graduate?
Way too old for that. Long time ago.
Yeah.
Prior to the internet.
Congratulations to another class, huh? And
yep.
I missed the graduation.
I told you should go tonight.
What happens tonight?
No, just put a robe on and go walk.
Oh, I should.
Yeah, I'm just saying you didn't do it, so just walk on tonight.
Well, I can tell you this: it is quiet around here, so that's kind of nice.
It's quiet, but it's windy outside. It's kind of blowing all of those mortarboards.
No, I have no idea what you're talking about. You are preempting a conversation that we're going to have today because this is the windy season.
It is. Yep.
April,
all we
May,
got going for us.
June,
sometimes.
Sometimes June. Okay,
Sometimes
we'll talk
June.
about the windy season. All right, so our agenda is a little bit of a recap of April and May, the May climate. We'll may even get into the June climate.
April showers bring May flowers.
Yeah.
No,
we didn't
they
get
really
much.
don't.
We didn't get much April showers.
No
and that's
flowers
actually that's an Eastern thing, isn't it?
It totally is.
Confusing me. And we should talk about some of the bigger stories here in the Southwest. And to me, that's the drought situation, which we haven't really dug into in a few years, quite frankly. But it's on the rise.
We do drought like nobody else.
It's on the rise, Mike. In fact, it reminded me of.
Oh, jeez.
All right, Mike. April is not one of my favorite months. Usually it's pretty boring.
Let's just get on to your favorite month. What's your favorite month?
I love July and August. I mean, the monsoon.
That was it, right? I just want to remember that because you're going to be in July and you'll be like, I hate this month.
No, from a climate perspective, July and August are the most interesting.
Okay.
But, I have to admit, April's pretty cool in terms of just amazing weather.
Yeah.
It's like cool mornings, pretty.
There you go.
Yeah.
See, it went from you just hating it to now you're like,
well,
it's not so bad.
I wear different hats. I think from a researcher's perspective, it's and somebody that's trying to talk about weather and climate and get people excited about it. What do you say about April and May? What do you say about May?
Well, you're going to find out.
Okay, so let's talk about the wind.
We're done, right? I think we're good.
Why is May so windy?
Transition month. We have a seasonal transitional climate in the Southwest, and we move from mid-latitude weather patterns coming out of the west. And as we go into April, May, and June, the sun gets higher, and the jet stream retreats to the north, and the high pressure builds in from the south. And in that process, we get kind of caught between the gears of these weather systems, and the wind kicks up. So
it's the high pressure system. So there's a gradient that's set up.
That's right. Yep. So it's surface winds in the mid-latitudes are a response to surface temperature gradients over horizontal distances. So if there's cold air at the surface near warm air horizontally, it's going to drive a pressure gradient, and that pressure gradient will then drive a wind.
So we get building high pressure in the south as the sun is the angle of the sun is.
Yeah, so you get surface heating, right? So we have warm air to the south. The continental climate of the U.S. in late winter into spring is still quite cold. And as it dries out too, you get a lot of radiational cooling. So you can have a lot of cold air just to the north of us with these storm systems colliding with, the warming surface of the parts of Mexico. So we get into these pretty strong temperature gradients over short distances, and we suffer the wind because of it.
What about the passage of low pressure systems?
Yeah, it's kind of all related. So those low pressure systems at upper levels are going to be related to and sort of force these surface temperature patterns across the west, and so that's also going to be part of the process as well.
And that sort of situation appears in mid to late April, or probably early April, right?
Okay, so seasonal transitional climate. What does that even, just in first principles, mean? Is that when we think about the Southwest having a seasonal transitional climate, we have strong seasonality in the sense that we have a wintertime season that gives us our one shot at precipitation out of two in the whole year. And that is driven by mid-latitude storm systems. So they're coming out of the west. They're interacting with the jet stream. They're driven by the jet stream. That jet stream is driven by the temperature gradient from north to south, cold poles, warm equator. And in that zone, it's going to drive those weather systems, and we're going to be part of that mix of weather in the winter season. So starting kind of November-ish, it's not been that clean and clear. December, we're usually into it. January, February, March is kind of our prime season, right? This year, game over, right? We didn't have much of that action at all. By the time you get into April, the whole northern hemisphere is starting to warm up. We're starting to get more sun in the northern hemisphere. The jet stream is going to follow that cold air to the north as it retreats around the pole. Jet stream is going to respond to that. So we're far enough south that we start to, at the beginning of the spring, already get out of the action of the jet stream, right? So the jet stream is now really starting to bring storm systems to our north, which is what we saw, right? We saw in April the Intermountain West and the Northern Rockies still see the storm systems while we were on the warm and dry side of those storm systems as they passed by.
Now, occasionally we do get storms in April and May.
Yeah, and even historically.
And so what would be the pattern that would set up that would actually cause the jet to sort of wiggle down?
Yeah,
further south.
It's going to be most likely something upstream. So upstream across either in the Pacific Ocean. Sometimes it's El Nino La Nina forced. Even in the 15-16 El Nino, we had kind of a mixed up Pacific Ocean jet stream variability, and we saw some weather extend into April and even into May with the storm track. And then there can be other just sort of natural variability components of it, stuff that's happening over the North Pacific, all the way over East Asia with East Asian jet. Send wiggles downstream. We can get into the action there. Typically, though, we don't have any moisture to work with. The East Pacific is not going to give up much water at that point, and it's going to have to come out of the North Pacific, and it's tough to precipitate out.
And it's also getting warmer at that time.
Yeah, absolutely. Yeah, right.
So warmer climes would then mean whatever moisture that you have, it's sort of harder to wring it out.
Exactly, right. So as you get into April and even later into April and into May, the storm systems that come by, even if they have moisture, it's in a warmer atmosphere, so you're further away from 100% relative humidity. It's harder to then just squeeze out that moisture.
Would you ever get anything sort of wafting in from the south?
Yeah, we actually had I had one of those 10-inch rains. I'm doing air quotes right now, meaning that there were 10 inches between drops as it fell, and it got my car all wet. We had a bunch of virga, which is raining at higher altitudes, and then it falls into a dry atmosphere. But some drops actually made it to the ground. It was on a Sunday in April where we had the buildups.
And you wake up in the morning and there's like dust on your windshield.
Yeah, exactly. Yeah, this was like in the middle of the day. We had these storm clouds that were pancakes. They were really, really high above the mountains, and they were thick, and they had cirrus tops on them and real, real high bases. They were just these squat little clouds. But there was enough moisture that was subtropical moisture kind of sneaking in up out of Mexico, and it caught southeast Arizona, a couple of lightning strikes, a little bit of rain here and there. That's kind of pre-season monsoon kind of action.
Preluding that. Well, maybe that's a forerunner.
No, I'm not buying that. It can happen all the time. Yeah, anything can happen. May's an interesting season, and May's a really good season for cutoff lows. You can get the breaking waves out of the active jet stream at higher latitudes will sometimes orphan a low pressure system in the East Pacific, and it can wander around. And typically what those will do will generate cirrus clouds. And so you'll get those kind of weird hazy May days where there's cirrus. There's no precip. Sometimes the wind's up, sometimes it's down. But
I think the point climatologically is that in these months, those episodes are just fewer. They become fewer and far between.
May is not a month of necessarily doldrums. There's a lot going on weather-wise. It just doesn't, especially in southern Arizona, do much precip-wise. The northern part of the state and higher elevations can pick up May precipitation, but it just certainly doesn't happen every year.
Well, let's look at, so this is for all of Arizona.
Lots of variability from year to year.
A lot of variability. It's all, obviously the totals are low. Most of the years fall below an inch. I mean, and that's actually quite a lot for southern Arizona.
Right.
In that sense, I mean, November, December, and January and February, the peak winter months, only experience about an inch of rain anyway.
Right.
So,
right.
But yeah, so there's, about half the years are a tenth of an inch or lower, and about half the years are above it, up to about an inch. There was one year, 92. You remember 1992?
I was alive. But I wasn't here. Yeah.
What was happening in 1992?
I actually graduated from high school.
Really?
Yeah. So it's graduation. I probably had a mortar.
Where was that, Michigan?
Michigan. Yeah. Yeah. You know what? 92 was.
So 2 inches in Michigan is probably, that happens.
You get that overnight. You wake up and you go like, it may have rained. I have no idea.
You get that while you brush your teeth?
Exactly. Yeah, exactly. So 92, I do remember. I was a weather nerd even back then, but that was the year without a summer.
The year without a summer.
Seriously, it was. It was super cold. It was a La Nina.
You know what? This was a year without a winter rain.
It was a year without a winter.
But last year, we got half an inch. We got, I think, one event, if I remember correctly. Or
what are you talking about?
Last May.
Really?
Well, I don't know. I'm looking at the data. Oh, this is Arizona-wide.
I'm sure
not
somebody did. Yeah. See, okay, to your point, there is a gradient across Arizona in May. So the southern part of the state very, very rarely picks up.
That's a good point.
So you get further north, like Flagstaff, on average, can pick up an extra inch.
Well, and that relates to what you were saying before. Yeah. I mean, the jet stream is actually retreating further north. So obviously, the further north you are, the more chances you have to get some of that
pivot point.
Okay, May is also the time where we start seeing our peak temperatures cresting into the hundreds.
Yeah.
Last month we had a bet about the first.
Did we? Did we do ice break on that? Yeah.
What was it? It was the date of the first 100-degree temperature in Tucson. I believe you said mid-May. I said something like April 18th, and I believe the earliest on record in southern Arizona was 19th. So I was like,
unlike you to go 5 standard deviations out.
So you went climatology.
Of course, I'm a climatologist.
Yeah, and I just didn't know what the climatology was. Or I clearly would have done that because that's the safe bet.
Of course.
Turned out May 6th. Okay. May 6th was the first day in southern Arizona, well, in Tucson.
Okay, so was the climatology the 15th?
Yeah, it's been getting earlier through time. I think when you average it over the entire period of record, it's like May 25th. But, in the last 30 years, I believe it's, May 17th. And, a little bit more climatology for everyone. But the average in the 1981 to 2010 period for the number of 100-degree Fahrenheit days in May is 4. Now, it was 3 in the 71 to 2000 period. And then if you go back another 10 years, it was 2. And, the 1951 to 1980 period, it was 1. So, it's been steadily increasing.
Yeah.
And of course, as you go into the summer, June, obviously we experience more days of high maximum temperatures over 100. I believe July is the peak month. July 18 out of 31. So a little bit more than half of those days are above 100.
It's interesting. I was looking at a little bit of the data for Tucson too, and in 2016 there wasn't a single 100-degree day in May, and in 2013 as well.
And there has been, how many have there been? Just one? May
this
6th?
Year?
Yeah, I mean May 6th was the first one. So
yesterday was 102.
Okay, so 2.
So we've had 2.
Well, that's what we had to look forward to.
That's why it's your favorite month, right?
More 100-degree Fahrenheit days. Woohoo!
Yeah.
We didn't talk about rainfall really.
Right.
It's been not a lot. Yeah. In fact, we said this last time. There has not been in southern Arizona, for the most part, rainfall since the mid-February event. If I'm correct, Mike, fact check me here.
For Tucson, that is correct. Yeah, but other parts of the state have actually picked up spits, basically. Spits. That's a technical term.
Trace amounts?
I think it's an acronym. Yeah, trace amounts. There was actually a storm system that right at the crossover from April into May, right at the time that the Tinder fire was actually picking up. So the Tinder fire was a wildfire to the southeast of Flagstaff, burning up on the Mogollon Rim, had picked up and burned in some really intense fire weather in late April with the wind that we were actually talking about and some of these low pressures coming by. One of the low pressure systems actually had enough moisture with it and was cold enough, and it was what we were talking about too. This was actually a quite cold storm, so it didn't even have to have as much moisture, but it put down a bit of snow on this wildfire in late April. So I mean, they were dealing with very intense fire danger, and then all of a sudden had snow on the fire, which took the edge off of it. But then
Actually,
quickly,
it was quite fortuitous.
Yeah, quite fortuitous. They still I don't believe they have it under control as of yet. And right on the heels of that storm, the temps went right back up above average. And so the whole state's kind of baking out again on the heels of that storm. But that storm did drop some measurable precip in Flagstaff. And Winslow, interesting enough, which has not seen much precip at all. Winslow ended up picking up about 9/100ths of an inch, which was a third of the total precip they've had in October. So it was not been good. And we'll talk more about sort of the drought conditions across the state.
Obviously, this is a time of year when fires pick up, just generally speaking. But given the situation that we're in right now, I mean, this looks like we're in potentially for a pretty bad fire season. I mean, it didn't necessarily start early this year.
It really didn't. We have all these fire weather stations across the state, and they're typically on Forest Service lands, so the remote automated weather stations, and they're usually on public lands, but they're all sort of sited, and they collect variables and data that evaluate fire weather danger on a daily basis. And so there are indices like something called the energy release component, which is an index to give you a sense of, given the weather conditions, of temperature, relative humidity, the potential fuel moisture in wood, that will give you an indication of, given how the weather has evolved over a period of time, whether or not you'd expect to see explosive fire growth. And that index in the early part of the winter was well above average, so say in January, because we didn't have any precip. And once we got into February, we had some of the precip across southern Arizona. You saw some of these fire indices just crater to sort of record low levels. And it wasn't more than a month later that they were back up above average to near record levels because of the heat building back in.
It is really interesting because we basically had one small period of rainfall this winter in that mid-February period.
But it was epic.
Well, right.
I mean, it was like such a weird winter because of the way it stacked up.
In a sense, I mean, that sort of reset the dial in terms of what you were just talking about in terms of fire.
It did, but it was real temporary. And that's what the interesting thing is, looking at these fire weather indices, which are really responding to sort of short-term variables in weather. Like, they moved that wet. And so again, remember, the February event cut through the southeast third of the state, and it was bone dry to the north of it and really wet to the south of it. The fire weather indices in the southern part of the state cratered. Nobody else did. Everybody else kind of bumped along. Like the Tinder fire had terrible fire conditions the whole winter. Ours, though, it took a month for us to go from below average to above average again on fire weather, because March and in April just turned right around. We're record dry and record warm again. So the benefit that we got out of that event was lost pretty immediately.
But had we not had that event, I mean, had we had half of what we ended up getting.
Our analog right now is, if you look at fire weather conditions or fire danger in, say, like the Tano National Forest or Apache Sitgraves or even Coconino, that's what Coronado would look like right now if we wouldn't have had that February. But it's we're probably catching up to that quickly as we go forward. So now we're in this race of fire season to get to July 4th, basically, right?
As soon as the monsoon, when the monsoon starts.
This fire season is all now about counting days now.
I say this every fire season, but the precip, the drought, the snowpack, the soil moisture, all of these sort of physical dimensions to fire are really important. But there's also the land management. There's also the campfires, other human things that cause half the fires in the Southwest anyway. It is a complicated algorithm. Nonetheless, obviously, the drier and hotter the conditions, the fewer snowpack, just the longer time that you're sort of in on the sharp end, if you will.
Honestly, this season, though, is not unlike 2002.
Well, it was 2002.
So 2002 is a drought of record depending on where you were at and what time period you're looking at, and basically those two aspects. And it was the year that we had the Rodeo Chattiskai fire and the Aspen fire down here in the Catalinas. So it was big, very destructive, out of control fires that erupted in late May and burned into June. So the background conditions are very similar. We've got stations all over the state now that are in their driest start of cool season precip records of their own, periods of records.
Yeah, we should also say, it's not just the snowpack and the lack thereof, which is obviously related to precipitation, but right. The low snowpack is sort of compounding because
Absolutely.
The snowpack sits on the landscape a lot longer than obviously.
Right. So you don't have the soil moisture. It stresses the vegetation out much earlier in the season because they're not drawing on the soil moisture. And then it's also the moisture in the fuels, the down dead fuels ends up it's just not there. So it's like a slow release of tempering fire danger up to the monsoon. It's just ready to go. It's ready to go right now.
Yeah. And then there's another important part of this, which, people always talk about like within like the global warming or the climate change, like how small a 1 degree temperature change is. This is a case where, 1 degree temperature change, 1 degree warmer conditions on a dry landscape just exacerbates it in sort of nonlinear ways.
Yep. And it's in the whole context of forest mortality. And we've got drought stressed trees that have been kicking off across the Southwest due to the climate change signal, the kind of creeping crowd of the increasing temperatures, the feedback that you're talking about with the soil moisture, the changes in sort of the pest dynamics that are killing off trees. All of these things converging on a drought year like this makes it a possibility that it's worse than even the drought that we had in 2002. The fuse is lit for this fire season, and to the point that the land management agencies are not screwing around this year.
What does that mean?
The fire restrictions, went into effect. I camped through the spring, and typically, even in the dry Southwest, you can go to a campground and have a campfire in late May.
That's right. A few weeks ago, or actually 3 weeks ago, I think
they're done. There was a period when, I can't remember, one of the summers several years ago, they closed Coconino Forest. They closed it. They closed the roads like they do in the wintertime where you can't drive anywhere. The summer rec was done until they started getting rain.
Yeah, I remember that.
So, that's when you get to the point where they're like, we're going to keep human ignitions down as much as we can. There was a news post that the Tano issued several hundred citations the first weekend that they put the fire restrictions into effect. So the land management agencies are out there. They're really trying to take
actively managing
the risk
this
seriously. Yeah, so that gives you an indication too that out on the land that people are worried.
Yeah, just to put the temperature in a little bit of perspective. So April temperatures across the West were above average to much above average. Actually, if you look at Arizona and the western half of New Mexico, even parts of eastern Arizona experienced their warmest April on record. And much of, actually, if you look at this map, east of the Colorado Rockies, or the Rockies actually that go all the way north-south through the U.S. East of that, it is below average, and west of it is above average, with the sort of the epicenter of the warm temperatures being over Arizona, actually.
That pattern is, record coldest April over the upper Midwest and record warmest for Arizona, for parts of Arizona.
Yeah, and when you look actually beyond April and going back basically 12 calendar months. The Four Corners states, so Utah, Colorado, New Mexico, and Arizona, if you look at that lump, warmest on record, 123 years. Arizona's the warmest. New Mexico was the second warmest. Colorado and Utah were the third warmest on record. And you couple that with, again, this is the last 12 months, which in terms of precipitation also combines both the monsoon and the winter precip. Arizona's seventh driest. Actually, that was surprising to me.
Yeah.
Seventh driest over that period.
Yeah, and so the only thing to pull us out of being the driest was July.
God bless July.
I know. It
was amazing. July.
It was an amazing.
I mean, again, that was like 8 inches of rain in
for Tucson
in 3 weeks.
Yeah,
I mean, that was it. So it was that period, and then it was the 3 days in mid-February accounted for probably 90% of our
That's
rain.
a good point, right? So yeah, if you look at the full year total, probably 80% of it came in 6 weeks.
We gotta have a bet. I bet it's higher than 80%.
You're probably right.
So between October and now, we've received a total of 2.58 inches. Within that mid-February period, 2 inches of that. So that's 80% of that rain came in that.
That's what I meant.
Yeah. Oh, okay. As long as we're clear now. In the monsoon season, the total was 8.5 inches. And in those 3 week periods in July received 7 of that 8.5 inches. So it's over 80%.
Yeah, you're right. Yep.
Boom. I win.
I meant 8% of average, which that's right about it.
Yeah, okay. I guess this raises a question for me. Does it matter, and in what ways does it matter that our rain comes in just two bursts? As opposed to maybe a more sort of characteristic winter and summer where you're sort of spread out a little bit more. You have a little bit more frequent rain, maybe the same amount, but a little bit more frequent. This is a unique. First of all, do you have any analogs that you can think of where years were basically the precip was basically concentrated in 2 short periods?
This extreme, I can't think of one as of late. It's not unheard of here, but it's certainly this year is sticking out as far as hitting the guardrails.
Yeah, we'll have to look into that.
Yeah, that's a really good question.
It does matter though that the rain only came in 2 periods. A little bit. It matters for the fire conversation that we were just having.
Yep.
It also seems like it matters for the drought situation, whereas sort of more frequent rain spread out over a longer period of time won't cause drought conditions. The description that people are giving to the drought, it won't cause them to be as severe.
There's so many different aspects of it. There's I think the fire one we just talked about, which is if it's not, we could even have had half that amount of precip we had in February, but if it was spread out evenly over a couple of months, it probably would have matched the normal rate of accumulation over that month, and it would have then kept sort of refilling soil moisture deficits that would have emerged over that period of time, right? So then plants have access to water, these fire indices, which are responding to short-term changes in relative humidity and drying out of fuels would constantly get sort of tamped down, right? So then you don't end up having these chasms that open up within the middle of a season where you got all this precip and then you don't really know where it's at or the soil moisture is responded to that quickly and is tailing off after that. The other aspect too is like having all that precip in July when we think about summer season, there's a lot of vegetation that needs to have some kind of tailing off through September and into October to just sort of, again, I think a soil moisture aspect. And then when we get into fall, a lot of our annual plants here are driven by fall precipitation. And so, like the wildflowers here we have a lot of annual wildflowers that if it rains in October and November, they emerge in January and February. And we didn't have it. We didn't have this year. And there's a lot of livestock grazing that actually happens off of annuals in the low deserts. And so that was an impact that you knew it was happening in October, November, and the impact didn't show up for months later when you saw that you didn't end up having the ecological response that you would have expected by having that. So even, again, you could have a below average winter, but if it were tailed out over that whole period, you'd have a completely different response in a lot of these different
also facets. In a way, receiving that rain in February, that's probably better than if it came in like mid-March, for example, right?
I was actually, in my mind, I was thinking it's probably better than it coming in January.
Why? Why is that?
Because it would have left, if we got all that in January, you're from January into February into March, you're moving into a warmer season.
That was my logic for why it was better than having received it in March. It stays on the landscape longer.
Oh, I see what you're saying. Yeah. No, you're saying it's a good thing to get it in March.
No. I was saying that it's better to get it in February than March because when you get it in March, the temperatures are higher. Oh. It would stay on the landscape.
Yeah. That's interesting. That's a good point.
But then again, if you got it in January, I think the point that you were making is...
You just get a longer time
for it. Yeah, you just have a longer time.
Yeah. Yeah. Then again, it probably goes back to where's the water going? How long is it staying in these different sort of reserves. I think getting snow versus rain really makes a big difference. And the February event was not a snow event.
Right. It was a warm event.
It was a warm event, long duration, super wet. It seemed to have had a real positive hydrologic response in a lot of kind of moving water around, recharging soil. But I think there's a lot of indications that it's probably gone. Every
time we have this drought conversation, I just
it's so
nuanced,
yeah,
right? Because I mean, you could get half the amount of precipitation, but if it was a cold storm and it was a lot more snow, that could actually be better for some impacts than the amount that we got under warm conditions. And obviously the timing, we just talked a little bit about the timing of it all matters. So there's all of these parts that are moving around that, we often talk about the monsoon being this existential experience, but drought's kind of the same way.
Oh yeah,
It depends on what your frame of reference is. If you're thinking about fire, obviously what you want or what you don't want is different than if you're thinking about rangelands, if you're thinking about, water impacts.
Right.
You have all of these different sort of classifications of drought, from hydrologic drought to snow drought to there's other agricultural drought.
I think if you look at a lot of these precip accumulation curves, the Tucson one is the most perplexing because it has that precip event thrown into the right smack dab in the middle of the season. So it leaves you with this confusion of, did it help? And what did it help? And how much did it help? Whereas if you look at some of the plots, like if you look at Winslow, it just didn't rain at all, right? So it's pretty clear. There's no nuance to that one, right? So some of the northern Arizona plots are terrible. They're just bad. Like it just didn't rain. And it's the record driest or the near record driest. So you'd expect the impacts to just be across the board. The Tucson one it's hard to know because it cut the deficit in half in 3 days for the winter season. And it was clearly great, but I don't know how much of an edge it took off of one sector versus another.
Right.
And I've talked to folks across Southeast Arizona who say this is terrible. That was a lifeline. It didn't do anything. It depends. And so this one it's even harder for me to try to sort out.
Well, so that's a nice segue because you mentioned the northern Arizona and the very dry conditions up there. It's a good segue to talk about the spatial print of drought, because we're entering into, at least by my estimation or by looking at the U.S. Drought Monitor maps here, we haven't been in a drought situation. You have to go back to August 2004 for conditions to be labeled as extreme as they are now, which actually caught me by surprise as well. You're looking at me,
right?
Yeah. You're looking at me in a weird way, but you can.
I have to fact check you on this.
You can fact check me.
So seriously, I thought it was 2006. Maybe you're right. Maybe that's the extent of. We probably have gotten worse than 2006, according to the Drought Monitor.
So I was looking at the amount of area labeled under extreme.
That's
or
right.
More.
Then. That's right. Because I think that 2006 had less area classified as exceptional drought at this point, right?
Right. Okay. So where we are right now, then for Arizona, the U.S. Drought Monitor sort of releases their drought maps. This is the product that most of the news outlets pick up. It's what's referred to when people talk about drought. Although drought, as we just mentioned, is much more nuanced than the picture presented here often. Close to 10% of Arizona is labeled as exceptional drought, and that's their highest drought category. It's like it falls in, looking at some of the indices that they look at, in the top 2 percentile of those products. So very dry conditions, historical records in many cases. 54% of the state is under extreme drought, which is their second highest category. 32 is moderate drought. Only 4% of the state is less than severe drought. So let me say that again. 34% severe, 54% ish extreme, close to 10% exceptional. That's where we are. If you go back right before the monsoon season.
Yeah, a
year ago today, it was basically no drought.
Last May, the drought situation was not similar at all.
No, we're basically under this product.
Half the state had no drought, and there was a small portion of it
that had moderate drought, which was not a severe category.
No, and it was the southern part of the state. That's right.
Right.
Yeah.
So now you can vet me on this. So right now we're at conditions that are more severe than they've been since when?
When I take a look at Drought Monitor for Arizona, we look at the historical time series. You can find similar conditions back in 2006. So the drought period that emerged out of the winter of 2006 and into the spring ends up having about 14% of the state was at exceptional drought. The entire state was under some form of drought, and about half the state was classified under extreme drought. If you look at the severe category, you have to go all the way back to, there was a period of time with the 2012, so kind of the 2011, 2012 period where we were skating into drought. That's where the severe category really took over. But the depth of the drought, like we don't see the exceptional drought category. We're not supposed to see the exceptional drought category. It's a 1 in 50 year drought event for a particular location at a particular time of year. So it's something that you shouldn't see a whole lot of. And we are, we're now at almost 10% of the state at that. You have to go back to the last time we had any exceptional drought in Arizona was in 2013. Then the 2011 drought period prior to that was at the height of the drought in 2006. And then you see this really pegged in Arizona, which is back to 2002, when we had the Rodeo Cheta fire and the Aspen fire down here.
Okay, so because you're involved in this product in some respects.
I'm
right?
the state for the Arizona. I'm in the state drought committee, which provides recommendations to the drought monitor.
So how is this created?
It's a weekly product with a set of rotating authors. The authors are at different agencies and different locations across the United States. The author coordinates through local experts through an email listserv and uses 24 different indices, products, maps to try to take the previous week's drought monitor map and adjust it based on changing conditions.
Is it an agricultural product? And I guess let me elaborate on that. When I look at these maps, you can see very clearly that drought has a sudden onset.
It can.
The rate at which you go from zero extreme drought to 20% can be over a matter of a few weeks or months.
Yeah.
And
yeah.
I mean, that to me is reflective of more agricultural in the sense that, you're dealing with crops, shorter term conditions really are responsive, or the crops are responsive to shorter term conditions.
Yeah. It's kind of known as flash drought. Flash droughts don't necessarily happen in Arizona. They happen in the Midwest and in the Great Plains. I think that's a phenomenon that makes a lot of sense. Out here, the only time that I can see that we end up having that stark of a drought impact emerge or potentially emerge is if the monsoon rains come in late. So if we are at the end of July and it hasn't rained, that to me is a situation where you could go full tilt on moving from like no drought to an intense short-term drought situation. Our large shifts in Arizona in the Southwest are, in a lot of cases, us catching up.
You're waiting a little bit for that.
Not waiting, but more catching up. Maybe not intentionally waiting, but more seeing how the situation has evolved that maybe we weren't totally had our head around, and then going, oh, we really need to kind of lean on this.
It's conservative in that sense.
It is very conservative, maybe too much in some respects, because we end up having to wait to hear how bad things are. So we're kind of late to the game. And one of the issues I think we really struggle with too is when to turn it off. We're going to have a real tough time as the monsoon comes in this summer.
We described where we are right now. And obviously we're into a time when there's no hope for precipitation. It's only going to get warmer. I mean, I shouldn't say there's no hope. There's very little hope, or you wouldn't expect it.
Right.
Like, is this something where drought's going to get worse?
This is a philosophical discussion in the sense that can drought get worse in a dry season, in a dry place? I have always been in the mind of not necessarily pushing drought conditions in a month like May because you wouldn't expect. But there's the counter too, which is, are we having intensifying drought conditions because of temperatures being warmer than they should be? Can there be a drought pressure by having warmer than average temperatures?
Well, that's interesting.
It
because
is, isn't it?
Then in the season, in a particular season, the drought it's not a rain thing.
It's not a rain thing. No, it's a water balance thing. It's like a research interest of mine now too. So if May is warmer than average, is there more intense drought? Or is there a possibility of having a drought intensification? Probably so, but it would it's completely depend on what you're talking about, and if it was cooler than average and it didn't rain, would that mean that you'd end up having less of a drought impact? Could you reel drought in?
But would you just be nipping around the margins like with temperature and like?
I think yes. Yeah. So which is why I end up not arguing for dramatic degradations in dry months. What I like to see is like to see a lot of action when a wet month isn't wet, but not on the other side of it. Mm-hmm. So what I'll be looking for this summer is looking for a late monsoon, and then I wouldn't have any problem of like pushing hard on, but it can't get a lot worse on this. But it's on the counter is like, if we have a really wet July again, how much of this do we pull back?
Right.
Because some of these impacts are actually going to be on the landscape until next winter, and they won't actually ameliorate until you get winter precip again. So even if it rains, you could still end up having a remaining impact.
So when you're thinking about how much do we pull back on that particular question, I sort of frame this as, is this an agricultural product? Mm-hmm. When you're thinking about how much to pull back on it, it's not just thinking about crops.
Nope.
You're sort of integrating all of these impacts, these concerns.
The drought monitor used to have, and you remember this, it used to know ag versus, do you remember, water versus, it had sectoral impacts on it. They got rid of them, and it's now short and long-term drought. And so it's supposed to be this timescale drought.
Sort of aligns a little bit.
Kind of. But it doesn't mean the same thing depending on where you're at, right? It's going to have this sort of local nuance you can draw out of it.
I think we should say, because we had a pretty good in terms of total monsoon precipitation, we had a pretty good last monsoon season. The drought conditions now are solely a product of the winter.
They are, but I don't want to take away how awesome the July was last year.
Oh, that's true.
Do you know what I mean?
It's a good point. The picture doesn't derive just from one metric of the monsoon, a total amount. It also is about frequency. It's also about other things.
So say, for example, we hit average last monsoon, but we had a wet period for a couple days in July, a wet period for a couple days in August and September. But it wouldn't stick in your mind as being an awesome monsoon, right? And it probably wouldn't for me either, because we'd end up having these clusters of thunderstorms and then these hot, miserable days in between it. We got another burst in August. We got another burst in September. Climatologically, it probably looked great, and it probably had a better effect in the way the delivery of the precip, depending on what the sector is we're talking about. But it wouldn't have been as spectacular and mind-blowing as the July we had, followed by the epic dry August and September. It's a perception thing. That August and September dry down was a problem for a lot of sort of ecosystem and, kind of ag sector. And
we did not receive any dollop from a tropical storm or anything like that. In October.
Totally missed out on that action.
Yeah, since I lost my brain and I can't Google, did we hit all the talking points, Mike? You got anything else you want to say?
You just have to give us the ENSO forecast and the monsoon outlook.
The ENSO forecast. I think that there's some warm water in the subsurface that gives a hint that it might be an El Nino. There doesn't appear to be any sort of
we haven't heard this before.
Overly strong signal.
Never heard this before.
This time of year anyway, I think we should make this point. And so for our neck of the woods, ENSO becomes less of a predictor of what's immediately in front of us.
Yeah.
It's more of a predictor of winter precipitation. I mean, I don't think it's a predictor at all.
Works of our colleagues have suggested that La Niñas can lean us early. And so if we were going to rely on that, we can't, because we lost La Nina.
Right.
I think that signal's pretty much wound down. So we're back into neutral. So I think we're right with you. So climatology, baby.
All right. Betting on climatology. All right. So what's our bet then? Okay. How about this? Number of days of over 100 degree Fahrenheit temperatures in May for Tucson. Number of days.
Oh, that's a good one. We already have two.
So
can't be one. Don't bet one. 7.
You total 7?
Mm-hmm.
Okay. Climatology's 4.
Yeah.
We went over that before.
Yeah.
But it's actually increasing. So I would say, I think 7's a good.
That's pretty good.
But you know what? I'm going to go 9.
I knew you were going to go 9. I knew you were going
to
go 9. Yeah, I'm going to look back in the record. I think there's only been like 1 year with 9. All right, and then for next month, how many days over 110?
Ooh. Thanks, everybody, for tuning in, and hope you have a great May.
Happy graduation, Zach.
Happy graduation.
Good luck tonight when you march.
The Southwest Climate Podcast is a production of CLIMAS, which is part of NOAA's Regional Integrated Science and Assessment Program and is housed at the University of Arizona Institute of the Environment. Mike Crimmins is a principal investigator with CLIMAS, a professor of soil, water, and environmental science in the College of Agriculture and Life Sciences, and climate extension specialist with the University of Arizona Cooperative Extension. Zack Guido is a research scientist with the Institute of the Environment and UA program manager of the International Research and Applications Program. The podcast is edited and produced by Ben McMahon, research, outreach, and assessment specialist with CLIMAS.
My computer just shut down.
Did it really? What happened?
I just lost my brain.
Oh, no.
Okay, I can do this off the top of my head.
Good.
I can do this off the top of my head.
Yeah, let's do it.
No, I can't.